Okay, I'm back to do the second, the part two of the uh, full wave rectifiers, the diodes and rectifiers AC to DC series. And this is going to be the one involving our same old transformer but now we're flipping it back around so the center tap is on the product side, the load side. Let me bring up the actual circuit, and this is what I will build. Notice that I've gone back and changed the power supply, the signal source, to 10 volts, not 2 volts. And that is because this transformer, when we use it needing the center tap, it is a step-down transformer. So if I only start with 2 volts here, and I step down to whatever it was, 0.4 over 2, that's not even enough to turn the diodes on. So that will never work. So I need a 10 volt source over here. This is a peak value, just like it says, 10 volts peak. And then we get to use our transistor. So let me take a moment and readjust the camera, and we'll get the picoscope going and the whole deal here. So here's our I showed you this in one other. It's more, I don't want you to learn the instrument. It's very cool and a lot of settings and so forth, but it's not, you know, basic user friendly. One dial, but you got to push lots of buttons to change frequency or any of those things. So just let me tell you, I have set it to be 10 volts peak. And let's pull up the picoscope and see if we can show that. Well, here it is running around like crazy. I'm going to add a trigger and stop the signal, and then we can talk about it. So here's our usual sine wave coming in. And notice I really had to turn up the value here. Should be on AC, but I really had to turn up the value. It's auto, and the peak value is 20 volts. So if I made it like plus and minus 10, you'd see, oh boy, it's jumping all the way up to 10 and all the way down to minus 10. Okay, but just so we can see it better, I'll crank it down. It's still 10 volts. It's just the display that I've turned down. See, this peak is between 8 and 12 volts. We can check on it, 10.12, something like that. All right, so that's what's coming out of the signal source, and here I have just attached it. This is the oscilloscope. This is the picoscope. It's what you're seeing on the blue trace on the screen is coming out of this. Here is the signal generator connected to the two wires of the transformer that we've been using over and over again. Now here's our back side. I've wired it up. You can see in the screen the orange and the red. What you probably don't see is the center tap here. I'm rubbing my finger across it. It's in white. Against the white background is a little hard to see right off. And I don't have here I can place an eraser under it, and maybe you can see it better then. Yeah, there you see the center tap. Okay, and I've just run it over here to a simple circuit, which is, here's the center tap coming around. I ran it in the channel there. Here is the resistive load. That's this right here. A resistor. Almost any value will do in this. And then here are two diodes, 1 and 2. Okay? Barely see those little glass diodes, these two right here. That's these diodes. So I have wired this circuit up, and I've got the B channel, the second channel of the oscilloscope. I am not displaying it yet. Second channel of the oscilloscope is right here. Right now I can use both grounds because one ground is attached over here for channel 1. The other ground is attached over here for channel 2. But they're magnetically coupled so they don't interfere with each other when I go to display them. And let me show you that. I will turn this one on, and I'm going to turn it up to a few volts here because it's got a few to give. Okay, so it looks like it's something like 2 or 3 volts. So let me turn the display up a little bit so you can first see the shape. Now notice what's happening. What's happening is it's full wave, right? When the blue signal goes positive, the red signal goes positive, right? Now here, when the blue signal goes negative, the red signal goes positive in the same way that it did before. So over here, what's happening, if you go back and look at the AC to DC lecture, and I talk about this center tap circuit, there's this circuit up here is on, and this one is off. And then they reverse. This one is on, and this one is off. And that's what's happening right here. The upper one is on, and then the lower one is on. Okay, and the opposite one goes off. Now the nice thing with this cranked up blue voltage at 10 volts, I got plenty of voltage when I get across to the other side. Because remember, 2 volts was cut down to 0.4 volts here. So that means 10 volts, which is 5 times 2, will be 5 times 2 over here. So it's cut down to about 2 volts on half of the windings. All right, and then that's got to pass through, or that's got to account for 7/10 of a volt getting dropped here across the 914. So 2 volts minus 7/10 of a volt is what's left on here. So 2 minus 7/10 is about 1.3. And if we go look at our signal over there, it's about 1.5. So probably we've got a little better than 2 volts coming off of the windings directly. Okay, so we could actually take a moment and just move the probe that's right here. We could move it over to the other side of the diode and see what we get. So let's just put it on the side of one of those diodes, and you see how it goes back and forth. Now I have to turn this voltage down a little bit. Whoops. Okay, so now you see it's clearly 2 volts over there. And the difference here, this is 2 volts, this is 10 volts, so there's the factor of 5 in these two values. That one is, if I get it right at the top, it's 10 volts. You see the A signal there. And here's the B signal. It gets measured at 2 volts. Once you're going to go back to the blue signal, and it's measured at 10. Okay? So we are seeing our 5-to-1 ratio going on between this and half of the windings. And then we're going to lose another, apparently only 5/10 or 5.55 if I move this back over here on the load itself. Got to connect it, and there that is. So if I'll crank that up in value so we can read it. And what do we get here? 1.6. So so these little glass diodes don't even have a full 7/10 volt. All right, now when you fill out this fillable sheet, the V peak is 10 volts. The VRMS, I can measure, I can do that quickly here with a multimeter, but you ought to know by now it's it's 7/10 of the peak value. We're still at 100, oops, we're not at kilohertz, we're at 100 hertz, 100 hertz, right? And then this is the measurements across here. The peak value, you're seeing it right there, is 1.6. And the RMS value, let me get those two values. So I'm going to turn on our, bring back in our, I'll shrink this back a little bit so we have room. All right, and I'll bring this back into the picture so you can read the values. And I'm going to turn it on for volts. And I'm going to measure AC volts. So this is going to measure RMS. I got to get it on AC. Right, it's telling me that here. It's AC and it's volts. And I want to measure the voltage across V1, in other words, the source voltage. I want to measure that over here. 7.02. So that's 70% of 10. Looks good to me. 7.02. That's the number that goes up here. Now let's look at it on the output. We see the peak value is, what did we say, 1.6. So this ought to be 70% of 1.6. So it'll be something just, what, a little above 1? Let's check it out. So that RMS value is 0.5. It seems kind of small. Oh, I know why. Ah, I fooled myself. Look, if we make this AC, that shifts it down. So that's a reminder. Here's the zero level. All of these bottom swells have been popped up. So now this waveform doesn't measure AC in the same way, right? Because it has no negative side. So the RMS value, it'll give us one, but it isn't going to be a terribly good number. So 0.56 is the RMS value measured down here, 0.56. Don't be confused now. This is not the same as 0.7 times this, because we don't have a smooth sine wave on the secondary signal, on the load signal. So a little bit funny. I'm just showing you. You got 0.56 down here and 1.6 here at the peak. This is 7 and this is 10. All right? Now the waveforms I want you to draw, here is V1. That's the blue line. That's the blue line. And then the second one is the voltage across the 1K signal. That is this one right here. And you know what? It's not in the figure, but as long as we're here and I've got the parts laying around, if we stuck a capacitor on there, let's see what happens. I wonder if this thing will smooth out for us. It will if I get it on the right pins. Between there and there. Oh, look how that's smoothed out. Wow. Smoothed out at what? Maybe 1.24, maybe 1.4, something like that. That too is a nice signal. Now it's nice because it's full wave rectified. There's both signals are there. It's full wave rectified. So that's why it's so important to do full wave rectification here when you can. Now you might ask, why does my wall wart use 4 diodes when I could get away with 2? Well, one of the answers is this is a cheaper transformer because there's no center tap to it. I'm sorry, the other one in the full wave is a cheaper transformer because there's no center tap. Center tap is another piece in the production, so that adds cost. This was a step down transformer, so you'd have to be very careful to get all that stepping down and stuff. So the windings are probably, this is going to be a little bit more expensive transformer because of the center tap and the need to have adequate voltage here. Okay, it turns out diodes are so cheap, what they really do, they don't sell you 4 separate diodes like I built with down here, 2 or 4 separate diodes. They don't do that. They just sell you a little package that has all of this wired up inside already. Not the resistor, but it has the diodes wired up inside, and all you do is connect the leads 1, 2, 3. The same is true with the bridge, the 4 diode arrangement. It has 4 leads coming out, and you just connect them up automatically. Okay, and it's just as cheap to make those as it is to build this. So they go with that because it's a simpler, easier thing. The transformer is simpler. There's less leads to connect, so there's fewer production problems. All right, I think we're done with the labs. You can submit this and fill it out and submit it. Look at this as many times as you need to get the numbers. And we're done here with labs and lectures. But I'll see you on Wednesday.